This is my first circuit. Here we have a NOT gate. Here we have a 4 input AND gate. Then here we have a OR gate, the LS32. My values for A are 1, my value for B is 3, my value for C is 5, and my value for D is 7, and that 8. So 2, 4, 6, and 8 are not connected to anything. And here we have an off position. If I turn on A, that's my first on position. My second on position is A and D. My third on position is just A and C. So let me turn off D, turn on C. Alright. Now my fourth on position is A, C, and D. And my fifth and final one is A, B, C, and D. Right? Just an overlook of my circuits. Here's my second circuit. We have a NOT gate, 4 input AND gate, and an OR gate. At A we have, at 1 we have A, at 3 we have B, at 5 we have C, and at 7 we have D. So our first on position is C and D. It turns on. Our second on position is B, C, and D. So B turns on, and that's on. Our third on position is A, C, and D. So B off and A on. That turns on. Our fourth is just A and B. So off D and off C and on B. That turns on. And then our fifth one is A, B, and C. That's on. Then our last one is A, B, C, and D. That turns off. That's just an overview of my circuit there. I've got a NOT gate, a quad input AND gate, and an OR gate here. This is what it looks like constructed. Here we have 1, it corresponds to A, 3 corresponds to B, and then D corresponds to 7. My reduced logic equation does not include C, so C, which would usually be 5, is not connected. Alright, our first on position is all zeros, and that is on. Our second on position would be with A, B, D off and C on, but since C isn't connected, that's essentially the same thing. Then we have A on, that's on. Next we have A and C on, which is essentially the same thing. Next we have A, B, and D on, and that's on. And then we have A, B, D, and C, which, since it's not plugged in, it's essentially the same thing there. And that's overview of my circuit.